I'm Jenny from IT department. For this semester, I have allotted to Introduction to Operating System CS3451 for second year IT department. Course outcomes are understand the course outcome 1 for understand the various scheduling algorithms and process synchronization, and course outcome 2 analyze and contrast deadlock prevention and avoidance algorithms. Course outcome 3 compare and contrast various memory management schemes, and course outcome 4 understand the functionality of file system, input output system and virtualization, and course outcome 5 compare iOS and Android operating system. Syllabus is unit 1 introduction about operating system. What is operating system? Structure, overview of operating system, structure of operating system, evaluation of operating system, system calls will be covered in the unit 1. And unit 2 process management. What is process? Process scheduling, process states, threads, multi-thread. So all these covered in the process management. Then unit 3 memory management, unit 4 storage management, unit 4 virtual machines and mobile OS. Operating system. What is operating system? An operating system is an interface between a computer user and computer hardware. An operating system is a system software which performs all the basic tasks like file management, memory management, process management, handling input and output, controlling peripheral devices such as disk drives and printers. Then our next topic is evaluation of operating system. So evaluation of operating system in the 1940s and 1950s, that is first generation. So first generation 1940s and 1950s, computers worked without an operating system. Programs were written in machine language. We can do one task at a time. So programs were manually loaded and run at one at a time. 1950s and 1960s, second generation, that is batch operating system. So batch operating system, jobs were collected and executed in batches, no user interaction during execution, used punch cards. Then 1960s, 1960 to 1970s, that is third generation. So 1960s multi-programming. So multi-programming loaded into memory, CPU switches between programs, improved CPU utilization. So introduction of multi-programming. So CPU utilization allowed multiple users to interact with a single system. 1970s, Unix and personal computers. So Unix revolutionized to operating system designed with simplicity, probability and multitasking. Personal computers emerged leading into simpler OS like CP bar M 1974 and PC DOS 1981. Then 1980s. So 1980s is the fourth generation, that is graphical user interface and networking. So graphical user interface gained popularity with a system like Apple Macintosh 1984 and Microsoft Windows 1985. Networking features like TCP, Transfer Control Protocol, Internet Protocol in Unix become essential. Then 1990s, 1980 to 1990s is the fourth generation. So fourth generation, Linux and advanced graphical user interface. So system network, Linux introduced open source development, Windows and Mac OS refined graphical user interface and gained widespread adoption. So 2000s, sixth generation. At present advanced mobility and cloud. So network and distributed operating system. Systems connected through networks, resource sharing, client server model. Example Windows 2000, Linux, so on. Then Cloud-based and virtualization technologies reshape computing with the operating system like Windows Server and Linux driving innovation. Modern operating system to 2010 present mobile and cloud-based operating system. AI integration, support IoT and small devices, high security and performance, support IoT and small devices. Example, Windows 11, Android, iOS and Mac OS. Then operating system structure. An operating system can be built using different structures depending on how its components are organized and how they interact inside the kernel. System structure acts as a blueprint that shows how the operating system is arranged and understood and adapted in different needs. OS design is complex, breaking into smaller manageable parts makes development easier. So, operating system structure, we have different structures. One is simple structure, second one is layered structure. So, we have a lot of simple structure. First one, simple structure, simple OS structure. The simple structure, the person who uses the computer where commands through apps or programs. These are a simple structure. In the simple structure, in the diagram shows application program, resident system programs, MS-DOS device drivers, ROM BIOS device drivers. So, application program software like browser, BAT, games. So, request services from the operating system. So, operating system control and manages CPU, memory, file devices. Second one, resident system program. Resident system programs are the core parts of an operating system that remain permanently in a main memory, random access memory. That's while the system is running. The purpose of resident system programs is control system operations, respond quickly, the system request, manage hardware resources, main resident system programs like kernel, process scheduler, memory management, input output management. Then MS-DOS device drivers. Come to them. MS-DOS are small programs that help the operating system communicate with hardware devices like keyboard, mouse, print, etc. Next one is ROM BIOS device drivers. So, ROM BIOS device drivers built-in drivers stored in read-only memory that help the computer start to and perform basic input-output operations. So, next structure is layered structure. So, layered structure is operating system is divided into multiple layers. So, top to bottom. So, middle part, top and bottom part. So, each layers use the functions of the layer below it. So, also debugging because errors are isolated to specific layers, adds overhead due to data passing through the many layers, and layered structure is an operating system design where the operating system is divided into layers. Each layer perform a specific function. Adds overhead due to data passing through the many layers. Layers can only use lower layers. In the Unix is an example of layered structure. The diagram shows layered structure is an operating system design where the operating system is divided into layers. So, each layer performs a specific function. Top layer. So, top layer user applications, user or application layer. Then bottom layer, layer n or top layer denoted to user or application layer. Then bottom layer it's a hardware part, that is layer 0, and middle layer or layer 1 is the operating system function. Different functions like file management, network management, process management, input output management. So like this, doing some operating system functions. Then modular structure. Then modular structure uses a kernel that contains only essential core components, while additional services are added to loadable modules during boottier runtime. Kernel contains only core components. It's widely used in modern systems such as Solaris. Extra services are added as a dynamically loadable modules. More flexible than layered structure modules can call any other module used in system like Solaris. So the diagram shows the modular structure. In center, the diagram represents the center is the core Solaris kernel. Around for independent modules. Each module provides specific services. Core Solaris kernel, center of the structure, the heart of the operating system, handles, process, memory management, device and bus drivers. Memory management. So device and bus drivers is the part of the modular structure that is control hardware devices. Example, keyboard, disk, mouse. Then come to scheduling classes. The scheduling classes decide how CPU time is shared. Example, time sharing, scheduling. Then executable formats. So executable formats define how programs are loaded in and run. Then file system. File system provides services that programs request from the operating system. Then come to the stream modules. Stream modules used for input, output and networking, miscellaneous modules. Other supporting services, example security, kernel utilities. Then a system call is the way for user program to request services from the operating system. These all are the modular structure. Then virtual machines. Virtual machines is basically software based computer that works like a real physical computer. Virtual machine run its own operating system and applications using resources from a single physical machine. The virtual machine, each virtual machines behave like a separate and independent machine, and through the CPU scheduling and virtual memory, operating system makes its appearance through each virtual machine has own dedicated resources. In a common example, virtual box is a common example for virtualization. CPU schedule and virtual memory give each virtual version dedicated like resources. The diagram shows a single physical computer is running multiple virtual machines. So virtual machine 1, virtual machine 2, virtual machine 3. At the same time, each virtual machine behave like an independent computer. Here is host hardware. So host hardware acts as a actual physical machine, includes RAM, random access memory, hardware like this, CPU. Then host operating system installed on the real computer, example Windows, Linux, Mac OS. Then hypervisor. The hypervisor, also called virtual machine monitor, runs on top of the host operating system. Each virtual machine contains guest operating system, and operating system running inside the virtual machine can be different form costs operating system. Example Linux inside Windows, inside Linux, Linux inside Windows, Windows inside Linux. So microkernel is a minimalistic approaches to design an operating system. Then monolithic structure. So monolithic structure is an operating system architecture in which the entire system is built on large kernel. All major services such as each having some memory operating system functions such as process management, means process programming unit ready to program in execution. So to give the scheduling like this, and the memory management, allocation, deallocation management, file systems like save the read the file, write the file, delete the files, and device drivers run together in a single code basic. Entire operating system is implemented as one large kernel. Include process, memory, and file system management. Device drivers also operate inside the kernel. So microkernel structure. So microkernel structure removes all non-essential services from the kernel and runs them in the user base, leaving only a small core called the microkernel. Then a hybrid kernel means that allows new services to add without modifying kernel, improving security and reliability, since failures in user space services do not affect the whole system. So non-essential services run in user space, leaving a small core kernel. So new services can be added without changing the kernel. More secure and reliable failures don't crash the whole operating system. Mac OS uses microkernel ideas within a hybrid external kernel. Then hybrid kernel structure. Hybrid kernel structure combines the features of both monolithic and microkernel architecture. The hybrid kernel structures designed either structure alone. Hybrid kernel structures combines monolithic and microkernel concept. It provides monolithic level speed and performance. So microkernel style modularity and stability. The results of hybrid kernel structure is a more flexible and efficient operating system design. The last structure is exokernel structure. The exokernel structure developed at MIT that gives applications direct control over hardware, that resources by separating resource protecting from resource management. So it design avoids imposing operating system level abstractions, allowing applications to customize resources needed. The exokernel structures refers to the architecture of an exokernel operating system which is designed to give applications direct control over between resources while keeping the kernel extremely small. So it's a extrakernel responsibility, security, allocate resources, provide illegal access, expose between directly. It manages physical memory pages, CPU time slices, disk blocks into buffers. It's a small minimal design that offers great developer freedom.